All right, let's actually do some transformations now. So we're going to put together what we talked about in the last two videos to draw a transform function. So to start, let's talk about what function we're dealing with here. We see the square root here, so we're dealing with a parent function. That's the square root function. So let's start by drawing that. So we can look back at the last video about parent functions and see how to draw that. So our parent here, I'm just going to write over here, I'm going to make a table of values, is y equals the square root of x. So I'm going to make a little x and y here, x, y, and let's write down those coordinates we use. 0, 1, oops, 1, I keep goofing it up, sorry. 1, there we go. Oh my goodness. 4, and 9. All right, so when we square root 0, we get 0. Square root 1, you get 1. Square root 4, you get 2. Square root 9, you get 3. So there's our key points, and I'm going to draw those on our graph here. So 0, 0, 1, 1, 4, 2, 9, 3, and I'm going to draw that half parabola that's sideways to end up with my parent function. Make sure we have an arrow on the one end and no arrow on the other because we can't input negative numbers into our function. Okay, so now it's time to start doing the transformations. But to do that, we got to identify our a, k, d, and c values. So remember, when we're looking at a transformation, if you look back at that parent function page, this is what our square root function looks like when you add all the transformations to it. So let's identify a and k first. So the a is the number out front, the k is the number inside the function. When I say inside the function, I mean inside the square root. The function here is to square root the x values, okay? The transformations are the numbers that are going on here. So we have a is negative 2, and we have k is also negative 2. So let's focus on the a first, negative 2. So there's two things here, like we said in the previous video. The negative tells me about a reflection. So since a is negative, I'm going to say that there's a vertical reflection. I'm just going to write VR for short today. The 2 tells me about the stretch. So ignoring the negative for a moment, the 2 tells me that there is a vertical stretch by 2. Now, if you want to be really technical, we'd say it's a vertical stretch by a factor of 2 because we're multiplying by 2. So that would be the most appropriate thing to say. So let's go here and we're going to make another table of values. I'm going to just kind of squeeze this guy in underneath here. And we're going to look at, it's a lot nicer if you do it next to it. It's a lot easier, but I'm going to kind of run out of room here. Maybe I could squeeze it in. Okay, so what we're going to do is we're going to do our stretches and reflections. So I'm just going to write short form stretch and reflect up there. So now the reflections and stretches and reflections, let's start with the y coordinates. We multiply all the y coordinates by a. So we said a is negative 2. We're going to multiply all the y coordinates by negative 2. So I'm just going to write negative 2 times y over there. So I'm going to take all of these and multiply them by negative 2. 0 times negative 2 is 0. 1 times negative 2. 2 times negative 2. 3 times negative 2. So notice we've transformed those points. Notice they're negative now where they were positive and they've gotten larger. So that's the reflection and the stretch happening. Let's look at the k values now. K is negative 2, but remember, we don't want k. We're actually dividing by whatever k is. So we're saying 1 over k. So that would be 1 over negative 2. We don't like that negative out front on the bottom. Let's put it out front or on top. So negative 1/2 the negative out front. Okay, so that's what 1 over k is. Now, what does that mean? Again, if it's negative, there's a horizontal reflection. So I'm going to write HR for short. And the 1/2 tells me about the stretch. So in this case, there is a horizontal stretch by a half. Now, to be clear, first of all, we really say horizontal stretch by a factor of 1/2. And this is technically really a compression. So if you want to be technically correct and sound smart in front of your teacher and friends, we should really say it's a horizontal compression. A lot of people just say stretch, but we're compressing it here because we're multiplying them by a half. They're getting smaller, right? So people say, well, how do I know if it's a stretch or compression? Well, are the numbers getting larger? It's a stretch. Are they getting smaller? It's a compression. Okay, so what we do here is we multiply the x coordinates in my table over at the side, 1 over k times my x coordinates. So negative 1/2 times my x coordinates. Now remember, if I'm multiplying something by negative 1/2, I'm really just changing the sign and dividing by 2, right? So saying multiplying by a half means divide by 2. All right, so all I'm going to do here is multiply them all by a negative, which changes all their signs except for the 0, and divide by 2. 0 divided by 2 is still 0. 1 divided by 2 is a half. 4 divided by 2 is 2. 9 divided by 2 is 4.5. Okay, no biggie. So I don't need to get a calculator and whatnot, right? Multiplying by half means divide by 2. All right, so I'm going to draw what this looks like so far. So 0, 0 hasn't moved. Now I'm at -1/2, -2, -2, -4, and -4.5, -6 down here. So you can see my graph has transformed, right? What's happened is, and make sure we have our arrow on the end there, it's now reflected. Notice that we have reflected it vertically. It's flipped like this, and then we reflected it horizontally to end up over there. So it's flipped both vertically and flipped horizontally to end up where it is. It's also been stretched vertically. So notice how after we flipped it, it's gotten a lot longer, right? It's gotten a lot taller or lower in this case. And notice how it's also been multiplied by the half. The x-coordinates have been compacted or compressed. They've been pressed in, right? Notice how it's gotten a lot shorter where it was a lot longer here. So you can see the transformations occurring. Okay, now we only have 2 more transformations to do. So we always do A and K first. The final transformations are going to be D and C. All right, so now the D and C, let's identify them. The D value is this one here. The C is here. Now, just to be clear, I'm using A, K, D, and C. I should have mentioned in my previous video. Different textbooks, different teachers, different professors might use different variables. So they might not be A, K, D, and C. It really doesn't matter the letters. I'm just choosing those because that's a common one I've seen in textbooks. They could be any letter, okay? The main thing is, what do these values, what do they do when we multiply? So multiply, add, subtract, do the transformations. So now, D is this one here. So as we talked about in the previous video, it's x minus D. So D is going to be a positive 5 here. I'll just put a plus in front to be very clear. And the C is the value at the back. He's very easy to find. It's going to be positive 6. All right, so what do they do? Let's start with D. What that causes is a horizontal translation. It's inside the function. Things that are inside, or in this case, underneath the square root, affect the x-coordinates. So horizontal translation, it either goes right or left. Since it's positive, we go to the right. Right, 5 units. So I'll just say right 5, but technically we should be clear it's right 5 units to the... Okay. All right, so now what that's gonna do is take this picture and move everything to the right 5. So how are we gonna accomplish that? Let's make another table here. Normally I like to do my tables next to each other, but I don't have the room, so I'll come down here and do my translations, my final graph. Okay, so let's take what we did before, and we're gonna take the x-coordinates, which we multiplied by 1/k, and we're gonna add D to them. So what I'm gonna do is, I multiplied them by -1/2 already. We're gonna add 5 to those. So here's my new table of values I'm gonna make. So take all of these coordinates and literally just add 5. 0 plus 5, -1/2 plus 5, -2 plus 5, and -4.5 plus 5. And that's what I end up with. Okay, so we got those points. So now, let's do the y-coordinates. This here the C value causes a vertical translation. It moves all your coordinates up. Now, if it was negative, it would move them down. So it moves them up 6 units. All right, so what do? Take what we did before, take all these coordinates up here, and just add 6 to them. So we've got A times Y plus C. So what did we do? We went -2 times Y. We just need to add 6. So take 0 plus 6, -2 plus 6, -4 plus 6, and -6 plus 6. And what that has done is taken all our points now and moved them up 6. So we've done 2 things. We've moved them over to the right and moved them up 6. So let's graph this new function. 5 over 6 up is right here. 4.5 over 4 up is right here. 3 over 2 up is right here. And 1/2 over 0 up is right here. Now we want to make sure we have the arrow on the same end we had it from the start. So our arrow, right, was on our last point, coming off our last point. We want to extend that a bit. Normally it'd be nice if we could extend it all the way through the graph, but we might want to find another point to do a more accurate job. So remember, I had the arrow on this point here, right? 9, 3. That's where it was coming off of in my original. So my arrow should be coming off of my last point of my table here. All right, and we drew it. It's been reflected, flipped, stretched, compressed, and moved all around. And we end up with our final graph.